Hello, this screencast is based on a question asked on Stack Exchange by user Nikos556, so thanks. And again, like last screencast, talks about calculations that don't go quite right and give a result which is not quite what we expect from the library. So, what was the problem? We have a fixed rate bond, semi-annual payments, so you can see that here, and all its several conventions. And the problem here was trying to calculate the price of the bond based on a given yield. So here it is. There's two ways we can do that in the library. One is we can ask the bond for its price, passing the yield explicitly. So we are passing the yield which should be used for calculation, and this gives us P1. Another way is to create a flat interest rate curve based on the same yield. So here we go, and create a discounting engine for the bond based on that curve, passing it to the bond, and then asking the bond for the dirty price without passing any additional arguments, because now the bond has all the information that it needs to price to return the price. And the results were somewhat different. Not a lot, it's a fraction of basis point, but still something which isn't explained and shouldn't happen. The problem here is the use of a particular convention, the actual bond, for accruing over the life of the coupon, which is unfortunately, is not something that we can really replace with something else. If that's the convention, that's the convention. The problem with this one, as opposed to several others in the library, is that this particular day count convention requires a reference period for its calculation. So we can't just pass the start and end date of the between which we want to accrue. We also need to pass some kind of reference period underlying the coupon. This is especially needed in cases like this one, this particular bond, which, as you can see, had a short coupon at the beginning. So this is 1 month, the coupon is 1 month, but as I said, since the rest of the bond is based on a semi-annual schedule, the accrual time must be calculated by passing to the day counter the start and end date for the coupon, but also the underlying reference period, which starts from which ends also on the end of the coupon, but goes 6 months backwards, so that the frequency is the same as for the other coupons. If we calculate this, we get this .0842 value for the coupon, and this reference date this reference period, is based on the frequency of the other coupons. If the bond were paying annual coupon, we would calculate this same year fraction as by passing start and end of the coupon and start and end of an annual reference period, and this would give a different result, so 842, 849. So the reference period changes the number in the calculation, and the corresponding discount factor given the yield can be calculated by the classes in the library, and the calculation is done internally. But this same calculation is done internally when we ask for a price based on a yield. So well, this is what happens inside the yield-based calculation. Well, of course, that's C++ code is different, but this is the idea. For each of the amounts, we get the corresponding accrual period, and here the coupon is able to pass both the start and end date and the reference period, the start and end of the reference period of the coupon, not just of the coupon itself. So here we get the correct T according to the convention and the frequency of the bond. We calculate the corresponding discount factor, and well, the discounts factors for discounting the cash flows are calculated by combining the discount factor over each of the periods of each of the coupons. What we get is something like this. So these are the amounts of the coupons, the accrual periods, so is half a year for all of the coupon except for the first, which has this value. This is the corresponding discount, so this is based on the 0.5, and so is this one. These are all the same, and this is the cumulative discount that we obtain by multiplying these ones. And finally, this is the amount that the discounted amount, so the coupon amount multiplied by the corresponding discount coupons. So these are the figures, and this is the final price of the this is the discounted amount of the redemption, and the bond price is the sum of all these discounted amounts, and it's equal to what we get by passing the yield, which confirms that the calculation I've shown above is the same which is done internally. What happens when we pass a curve to the bond? Well, what happens is that the discount calculation is different. The calculation asks the amounts of the coupons, but then retrieves the discount factors not by calculating the accrual periods and combining the corresponding discounts, but by asking the discount factors directly of the curve. The problem is that in this case, the curve is not doesn't know the reference period over which the time and therefore the discounts should be calculated. The calculation is something like this. We ask the coupon for the amount, but we don't get the date and the reference period information. We just take the payment date of the coupon and ask the curve for the corresponding discount. And then, well, we discount the amount and we add all of them. We get something like this. And so amount, the discount returned from the curve, and the discounted amount. By adding this, we get the same result as that we get from the bond using the pricing engine, which again confirms that this is the same calculation that it's doing. The problem is that, well, we might compare the various quantities, but we can see that the very first discount is not correct. Is 0.9971 against 0.99708, and this is 7119, and the amount, discounted amount, is correspondingly a bit different. And well, the problem is when we call the discount method of the curve, which is the first date, not having the reference period information, the curve translates this into a call to day counter asking for the refraction between the reference date of the curve and the past date. As you see, the reference date is missing. The reference period is missing, which causes the year fraction method to take it as the same as between the two dates. So we instead of the correct 6 month reference period, we are using a 1 month reference period here, and this results in the wrong result as compared to the correct result here. This accounts for the difference in price that we're seeing. So if we take the two discount factors, so the correct one, well, this one, basically the one including the reference period, and the discount factor returned by the curve, and if we account for the differences in these two single discount factors, so the first one, and we adjust the price returned using the curve, we are getting the same price that the yield-based calculation is returned. I don't really, well, this is an explanation of what is happening. There's no real solution for this now, except that telling you to use the yield-based calculation if you want to retrieve a price based on a yield, because inserting the reference price, the reference period calculation into the curve is, well, I'm not really sure it's feasible given the architecture of the library. There is work underway to provide the day counter itself with information, which means that there has already been a contribution to the library that allows one to pass a schedule when we create a day counter. So for example, when we create this one, we can not only specify the particular convention, but also we could pass the schedule of the bond to the day counter. This way, when the day counter is asked for the day fraction between two dates, it could go look at the schedule that it contains and pick up the correct reference price for this calculation based on the scheduled date. That's already in the library, but it still has a few problems. We're not sure that the calculation is quite right, and there is a pull request currently in GitHub by another contributor that proposed the fix. So it might be it still has to be checked because a few test cases fail, and we have to check if the calculation is right or the tests. So it might be either way. So this functionality might go in the next release or the one after that, not probably the one after. In the meantime, as I said, no real solution except, well, don't use the curve-based calculation, use the yield-based calculation if you want to calculate based on the yield. And with this, we are at the end of this somewhat rambling screencast. And thanks for your patience, and I'll see you next time. Bye.